Higher Secondary Examination 2016 Mathematics Full marks 100 Pass marks 33 Time 3 hours 15 minutes 15 minutes are given as extra time for reading questions. Attempt all questions. The figures in the right margin indicate full marks for the questions. Ye thangmana kanna lariba figure sing asina question sing asigi full marks sing tae. For question numbers 1 to 6, write a letter associated with the correct answer. Question 1 dagina 6 faubadi achumba option adugi chanaba letter adu e katang iu. Question number 1. Find the value of 10 of 2 10 inverse of 1 by 5 is. The value of 10 of 2 10 inverse of 1 by 5 is. Karamba chumbage hangagadi. Question asigidi 10 of 10 inverse of 2 times of 10 inverse of 1 by 5 is equal to 10 inverse of, which is again equal to 10 inverse of 2 times of 1 by 5 divided by 1 minus 1 by 5 whole square. 10 anisi kakthana kradi 2 by 5 lerani makhagidi 24 by 25 kakthana rabadi 10 by 24 amuksu kakthana rabadi 5 by 12. Correct option adu 5 by 12 already B chune. B. Correct answer is B, which is also solved. If f and g are functions defined from R to R by f of x equal to sin x and g of x equal to x squared, then fork is. Fork by definition. Fork of x is what? Fork of x is f of g of x. G of x is x squared, then which is again equal to sine of x squared. Correct answer is C. Correct answer will be C. Yes, C. Fork of x is f of g of x. G of x is originally equal to x squared. F of x is sine x. Therefore, for f of x squared, it will be sine of x squared, whether it is in this form or not. If matrix A is of order m by n and matrix B is of order 3 by 4, then product AB is defined only if A hariba matrix asigi order asina m by n, B hariba matrix asigi order asina 3 by 4 ni, then product AB asi defined to harabadi these two quantity is in managadaban. That will be n equal to 3 haragadi option A asire. The value of the limit of 1 plus x whole to the power 1 by x when x tends to 0 is. Sig standard limit ni, sig value the limit of 1 plus x whole to the power 1 by x tends to 0 is always E. And the correct answer is C. If x equal to t square, y equal to t cube, then d square y by dx square is equal to parametrically defined function ni dy by dx yan hana puthokani 1 mark ki damakta di koina sigi formula si sisinagani parametrically defined function gi di respective value di mathak ki di thrice of t square ni makha gi di twice of t ni Rabadi 3 by 2 times of t. Again, second order derivative haragadi piramiba function sida amuk derivative loksilasi. CD dy by dx, whose value is 3 by 2 times of t. This is function of t. Constant mamang chakrasi d by dt of t into dt by dx. Respective value di signa d square y by dx square. 3 by 2 t the tinalorabadi 1 into dt by dx di dx by dt की value di twice di 3 by 40 3 by 40 The correct option is B. Question number 6. If the line this is parallel to the plane this, then the value of P is line asiga piba plane asiga parallel oirabadi what must be true plane asigi singakpa any normal aduga line asiga perpendicular oigani perpendicular oibagi condition palabadi a1 a1 b1 a2 b2 plus a3 b3 sigi perpendicular condition pala what will be thrice p siga 2 ga purinaro plus 2 asiga 3 ga purinaro plus 1 asiga minus 4 ga purinaro equal to 0 6 of p this is minus 2 then p ki value d minus 1 by 3 correct option is b. Correct option is B. It must be B oigadabani. And P ki value the 1 by 3, P ki value 1 by 3 asi minus oigadabani. Question number 7. What is an equivalence relation? Equivalence relation ama aibase karina and a relation R in a set A is an equivalence relation if R is reflexive, symmetric, and transitive. Ahumak oiba relation amabu equivalence relation ko. Find the principal value of this. Sine inverse of. We have to remember this formula. Sine inverse of. We have to find out its value. For this, remember this. Sine inverse of sine of x is x. In this case, x should be lying between minus pi by 2, pi by 2. Then this can be written as minus pi by 3. When is a function fx said to be differentiable at a given point? Function nama point nama the differentiable oiba haibasi karino. A function f is said to be differentiable or derivable at x equal to a if 11 derivative at a equal to right hand derivative at a anisi manarabadi haibadi 11 derivative right hand derivative at a are finite and equal, that is 11 derivative at a equal to right hand derivative at a. Or limit of f of a plus x minus f of a by x tends to 0 exists finally. The radius of a circle is increasing at the rate of 0.7 cm per second. What is the rate of increase of its circumference? Circle namagi radius hengatpagi chang asi 0.7 cm per second. Mahaki circumference to c na kanarasi twice by r ne. Circumference hengala radius hengaladi circumference hoidan hengalani. Adudi c is t na derivative law twice pi lerani r dudi t ki function on dt. Pi ki value d koina 22 by 7 sinjalabasu yagani r di 0.7 ani se purinarabadi minus 1 minus 2 d minus 2 4.4 centimeter per second over. Given dr by dt is 0.7 centimeter per second, which is equal to 7 by 10 centimeter per second. Circumference c equal to twice by r. dc by dt we have this dr by dt ki value is 7 by 10 centimeter pi ki value na 22 by 7. After calculation we get 4.4 centimeter per second. When is a function fx said to have a relative minimum at a point x equal to c? For function nama point nama the relative minimum lay by karina. A function fx defined over the closed interval ab is said to have a relative minimum at x equal to c if f of c less than f of c plus h for all positive and negative values of I sufficiently small. F of x c na f of c plus h pumna makagi where I sebasi yamna pikpa positive obi yai negative obi yai aduguma value function value pumna maktagi mana piklabadi f of c sina minimum relative minimum value ni c asida relative minimum value lay haigan. Question number 12. Express integral of f of x dx between a to b as the limit of a sum. Its formula is limit of I tends to 0 of f of a plus f of a plus h plus f of a plus twice h plus dot dot plus f of a plus n minus 1 times of h, where h is b minus a by n. Write the differential equation obtained by eliminating the arbitrary constant c in the equation xy equal to c square. Hariba equation asidagi c manghalaga differential equation semu haibani. Arbitrary constant amukaktani amukakang iconic derivative logani. Differentiating both sides with respect to x, we get product rule palabadi x into dy by dx plus y into x load 1 equal to constant derivative 0, which gives x dy by dx plus y equal to 0, which does not contain arbitrary constant as well as it contains derivative, which is the required differential equation. Question number 4. State the triangle law of vectors. 1 mark. If let a vector and b vector be two vectors which are represented in magnitudes and directions by AB with arrowhead and BC with arrowhead, then their sum A plus B is represented in magnitude and direction by AC with arrowhead. Thus, AB vector plus BC vector equal to AC vector is in this picture. Picture is A vector, B vector is sum the AC directed from A to C and whose magnitude represents its magnitude. Write a distance of a point with position vector A from the plane disk. Apiba point C apiba plane stigera puthupagi formula do U haibani. The distance of a point with position vector A from the plane R vector dot n vector equal to Q is modulus of Q minus A vector dot n vector divided by modulus of n vector. Write a vector equation of a line passing through the point 137 and parallel to the line disk. Apiba point asi phawa apiba line asiga apiba point asi phawa apiba line asiga parallel over line gi equation putu haiben. The vector equation of the line is amount apiba point of position vector plus lambda or mu times of the parallel oibasing direction ratio sing proportional oigani adana 354 haiba apiba line asigi direction ratio sing asida magi ij kena purira phangani. This is the vector equation of the line passing to the given point and parallel to the given line. Question number 17. A binary operation asterisk on Z is defined by a asterisk B equal to A plus B minus 2, where AB belongs to Z. Find the identity element in Z. Find the inverse of x such that x asterisk 3 equal to 7, 3 marks. Let E be the identity element in Z. Then A asterisk E equal to E asterisk A equal to A for all A belongs to Z. Then A asterisk E value the A plus E minus 2 ni, and this is left and we get A. Cancelling A we get E equal to 2. This is the identity element for the binary operation asterisk on Z. It is also given that x asterisk 3 is 7. By definition, x plus 3 minus 2 equal to 7. X gives 6. And its inverse is inverse of 6. Let y be the inverse of 6, that is x. Then 6 asterisk y equal to 2, whose by definition 6 plus y minus 2 equal to 2, from which we get y equal to minus 2. Therefore, the inverse of 6 is minus 2. Prove that cos inverse x equal to sin inverse of root over 1 minus x square equal to 10 inverse of root over 1 minus x square by x, which is 3 marks. Let cos inverse x to y the putting towards a the. Then cos a equal to x. Cos a value khangabadi kona sin a value putoksi root over 1 minus cos square any cos a the x kamana root over 1 minus x. Now it is put in a. Therefore, sin formula is sin a. Now sin a in terms of this. Then sin a na sumsakra this sin sumsakra the a lehore sin inverse of root over 1 minus x square a your stand value the cos inverse x ni. cos inverse x equal to sin inverse square root over 1 minus x square. Again, tan sine y ga managadi tan sum ladi tan a in terms of sin a cos a the phongge quotient relation the respective values simple implies a value the tan sum la abadi tan inverse of root over 1 minus x square by x. A original value the cos inverse x equal to tan inverse of root over 1 minus x square by x. Therefore, cos inverse x equal to sin inverse of root over 1 minus x square equal to tan inverse of root over 1 minus x square by x. If x to the power y equal to 5 to the power x minus y, find dy by dx. Taking log on both sides, we get y into log x equal to x minus y times of log 5. Differentiating both sides with respect to x, we get y into log x with its derivative is 1 by x plus log x remains unchanged into derivative of y is dy by dx. Next product rule, first function derivative of first function is this. X its derivative is 1, its derivative is dy by dx log 5. And solve dy by dx. We get dy by dx equal to this. Prove that the integral of 1 by root over x square plus a square dx is log of modulus of x plus root over x square plus a square plus c. 3 marks. A square plus x square over the, we have to put x equal to a tan theta or a cot theta. Here we have put x equal to a tan theta. Its derivative with respect to x is, lastly we get dx equal to a sec square theta d theta. Then dx की value थमो, x की value थमो, a square कम लग थोड़ी रुकवामरे a लाई मतलब कि एक कथन नरे मखा की कथन नरे बदी tan square theta plus 1 is sec square ने square कर sec theta ले sec theta ने sec square theta दिया लो sec theta. Its derivative, its integral is log of modulus of sec theta plus tan theta plus k. Then sec theta expressed in terms of tan, we get root over tan square theta plus 1. Tan theta is equal to x by a. Therefore, tan square theta we have to put x by a whole square plus 1. And after calculation, we get minus log of modulus of x plus k. Then lastly, if we put this equal to c, which proves the result. 21. Solve the differential equation. Let us solve. Dividing in sum by y, we get this. This is a linear equation. This is a linear equation of first order whose integrating factor is e to the power integrand of p dy, not dx. And p is 1 by y, whose integrand is log of y. E to the power log of something is something y. The solution is x into integrating factor equal to integrand of q, that is 1 into y, whose integrand is y square by 2 plus c. Then x equal to y by 2 plus c by y. For question number 22, prove the projection vector of a vector on b vector which does not equal to 0 vector is a dot b by modulus of b vector whole square times of b vector, which is 3 marks. Let OA represents a vector, OB represents b vector, and angle AOA of b equal to theta. Draw a L perpendicular to OB. Projection of a vector on b vector is length of this length OL. This length is projection of a vector on b vector OL, which is from trigonometry in a right triangle. Base by hypotenuse is what? Base by hypotenuse is cos theta. This gives OL is equal to AA cos theta. Apply this. OA into OL by OA. OL by OA is cos theta, and OA is length of modulus of a vector. Then cos theta, from scalar product of two vectors we get this. Cancelling these two terms, we get this. Then projection vector. Therefore, projection vector of A vector on B vector is OL with arrow head. Then O, which is equal to magnitude of OL into a unit vector along B vector, that is B cap. And OL already equal to this. Put this value and grouping, we get this, which proves the result. 23. The function f defined by f of x equal to x square plus thrice x plus a when x less than or equal to 1 and bx plus 2 when x greater than or equal to 1 is derivable for every x. Find a and b for marks. It is given that f is differentiable for every x. So f is differentiable at x equal to 1. That gives left hand derivative at 1 equal to right hand derivative at 1. And for this f of 1 plus h, f of 1 plus h is a number less than 1. You have to use this formula, we get this. And f of exactly 1 is either this or this. And for right hand limit, 1 plus h is greater than 1. Therefore, we have to use this. Yeah. Expand and cancelling, we get h, put h equal to 0, we get b equal to 5. B equal to 5. One unknown is known. Then we know that every differentiable function is continuous. So f is continuous at x equal to 1. By definition of continuity at 1, we get left hand derivative at 1 equal to right hand derivative at 1 equal to f of 1. And taking limits in is, we get this, from which we have a equal to b minus 2, but b is already 5. Therefore, a equal to 5 minus 2 is 3. Thus, a equal to 5 and b equal to 5. A equal to 3 and b equal to 5. Question number 23. If square root of 1 minus x square plus square root of 1 minus y square equal to a times of x minus y, prove that dy by dx is equal to minus square root of 1 minus y square whole divided by square root of 1 minus x square formula. If we have seen 1 minus x square, we have to put x equal to sine of something. And here is also 1 minus y square. So we have to put y equal to sine or cos of another angle. Put x equal to sine theta and y here, y equal to sine of phi. We get this. Given expression becomes this. For this we have cos theta, for this we have sine pi. And sine chi of course in number formula policy, we get this sine chi number formula palo product of pongo for to kaktana krabadi lastly manavatam sing kakkrabadi sigi cos of sigi to sumisu kakrani both side agi cos of this kakrani susu kakrani, then cosigi cos sigi sine ni yellow rabadi, we get this cos. And quarter is sumisa cot inverse. Then we get theta plus pi equal to this. Theta की original value this sin inverse x ने, pi की दी sin inverse y ने. Taking derivative on both sides, we get with respect to x, we get for this, we get this, for this y. Therefore, we have to multiply by dy by dx. This is the concept of derivative 0. Solving dy by dx, we get this. Question number 24. Using integration, find the area of the region bounded by the parabola y equal to x square plus 2 and the lines y equal to x, x equal to 0 and x equal to 3 for marks. Here y equal to x square plus 2, y equal to x, x equal to 0 and x equal to 3. The required area, the area of OABC is in this picture. Parabola, this parabola opens upward and which does not pass to the origin as 0, 0 does not satisfy this equation. And x equal to 3 is a straight line parallel to y-axis at a distance 3 units from origin to the rightward, and y equal to x is a straight line bisecting the first and third quadrant, and the area enclosed by them is this shaded region. And this is what area of this portion between x equal to 3 to x equal to 0 in the x-axis tagi sigi line asina x-axis to same sigi area se khaidokhrabadi, we get this area between the curves phangani. Then mathaki curve asigi y gi value di mathaki curve asigi y gi value di silerani makage cup asigi y gi value the x ni. X ranges from in this area x coordinate is always 0. In this area x coordinate is always 3. We have to put this. Whose integral is this applied? We get this 21 by 2 square units. Question number 25. Evaluate this. Evaluate this. Evaluate means there is one sign is left. This sign. This linear by quantity. Linear by quantity. Its form is numerator equal to a times derivative of denominator plus b, whose derivative is the equating on both sides. We get coefficient of x is 5, coefficient of x is 6a, and constant equating constant term on both sides. For this minus 2, for this twice a plus b, and which gives a equal to 5 by 6, and put this value in this equation, we get b minus 11 by 3. Therefore I given integrand becomes this, and expanding this by this minus 11 by 3 times of 1 by dx by this. Sigi masidi yare integration loba sigi quadratic 6 digi coin 3 kama lopthokrani distadi 9 la ani. Then x of tamani si per p square sigi matak to makagi derivative or magi integrand log of modulus of denominator this. Si quadratic the x of tamani si quadratic complete perfecting square of constant do real number magi square of thamane. Then CD 1 by a 10 inverse x by a palani. 1 by a 10 inverse x by a. Then simplify it over the we get this. Or evaluate integral of cos inverse of root over x dx. 4 marks. Root over x. Radical number putting together hierarchy letter among square x to u square putting together derivative dx equal to twice u d u respective value pisele the cos inverse of u learning u to among chakra product rule policy. Integration by parts policy. 2 times of first function unchanged integral of second function minus derivative of the cos inverse is this into integrand of u the u square by 2. Again sig integral u square by 2 duga sig 2 ga kathana kare dislare. Then sig 2 ga 2 ga kathana ra minus u square simplified of a matak to 1 minus e square phone sele 1 is ni yembagi integral ama mangon ma ni yembagi integral ama sig su standard formula phare sig pura standard formula phare u gi original values into piselane sunna integral asig evaluation ni value pude. Question number 26. What type of differential equation is said to be a homogeneous differential equation? Write a stepwise method for solving a homogeneous differential equation. Karamba makangi differential equation amabu homogeneous differential equation haigani stepwise method ta homogeneous differential equation am solve to stepwise into u haibani. Stepwise. A differential equation of the form dy by dx equal to f of xy by g of xy, where f of xy and g of xy are homogeneous functions of x and y and of the same degree is called a homogeneous differential equation. F amasung z asi homogeneous function of xy with same degree oigadabani. Stepwise method for solving a homogeneous differential equation. Ahanba step, write the differential equation as the standard form of thamane. Put y equal to bx, that is y by x equal to b, so that dy by dx to see derivative load over d, we get this. Ahum sub step, substitute y by x equal to b so that dy by dx equal to b plus x db by dx obtained in earlier step in the differential equation. Simplify and separate the variables and get the new differential equation. Integrate both sides of the equation obtained in step 4 to get the solution in x and b. Replace y by b by y by x in the solution obtained in step 5 and get the required solution. 27. If a vector equal to this b vector equal to find a vector c such that across b is b and a dot c is 3 for marks. Let c equal to xik plus yjk plus zkk. Across c is given as b. By definition we get this. Equating both sides we get z minus y equal to 0, x minus z equal to 1 and y minus x equal to minus 1, equation 3. Also at dot c is 3. The scalar product is this, whose value is 3. From these four equations we have to solve x, y, z. Y is equal to z. Therefore instead of y put z, from which we have x plus twice z equal to 3, which is equation 4. Using 2 and 4 we get z equal to 2 by 3 and x equal to 5 by 3. Also y equal to 2 by 3. Therefore c equal to 5 by 3 ik plus 2 by 3 jk plus 2 by 3 kk. This is the required vector. Question number 20 का I. If P of A is 3 by I, P of B is 1 by 2 and P of A intersection B is 1 by 4. Find P of A bar by B bar. 4 marks. Given P of A is this, P of B, P of A intersection B. Therefore P of A complement is 1 minus P of A, whose value is 5 by I. Similarly P of B is half. Therefore, P of A complement intersection B complement is by De Morgan's law, which is equal to P of complement of A union B, 1 minus P of A union B, whose expansion is this. Put their respective values, we get whose value is 3 by I. Therefore, P of A complement by B complement is this. Putting their respective values, solve, we get 3 by 4. Question number 29. Define a symmetric matrix. Prove that every square matrix can be uniquely expressed as a sum of a symmetric and a skew symmetric matrix. Symmetric matrix ama masak ta'u every square matrix khudingmak symmetric amaga skew symmetric amaga anigi samda phongdokpa yai. Uniquely phongdokpa yai habasi prove to 6 marks. A square matrix A can be written as is said to be symmetric if A transpose equal to A. That is Aij equal to A of Ji for all I and J. We have A can be expressed as half of A plus A transpose plus half of A minus A transpose. Now, the transpose of this second matrix is this, using this property. Again, using this property we get this. A transpose of transpose is again A. And vector matrix addition is commutative, using we get this A plus A transpose, whose transpose is itself. Therefore this shows that this is a symmetric matrix. Similarly, taking transpose of this we get this, and from which we have minus times of itself. Therefore thus half of A minus A transpose is a skew symmetric matrix. First part is over. For second part, uniqueness. If possible, let A equal to x plus y, where x is a symmetric matrix and y is a skew symmetric matrix. Taking its transpose, we get this. Here, A equal to x plus y and A transpose equal to x minus y. From which these two equations we get x equal to this, which is equal to p, and subtracting we get y equal to this, which is equal to p. X and p are same, y and q are same, which contradicts our supposition that x and y are different from p and q respectively. Two differences are always same. Hence, A is uniquely expressible as the sum of a symmetric and a skew symmetric matrix. Question number 30. Define direction cosines of a line if theta be the angle between two lines with direction cosines L1, M1, N1 and L2, M2, N2 respectively. Prove that Roman number cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. Again, sin theta is equal to square root of this expression. 6 marks. If a vector OA max angles alpha, beta, and gamma with the positive directions of coordinate axes, then cos of theta alpha, cos of beta, and cos of gamma are known as the direction cosines of OA and are represented by small letters L, M, N, such that L equal to cos alpha, M equal to cos beta, and N equal to cos gamma. So second part, let E1 cap equal to this, E2 cap equal to this be unit vectors along the two lines respectively. Then cos theta is their dot product. Their dot product whose value is this. First part is over. Also, by cross product of two unit vectors, we get n cap sin theta equal to their cross product, which is written in determinant form, whose expansion is this. Taking squaring both sides, we get sin square theta equal to, for this we have this. Taking square root on both sides, sin theta equal to this. We have proved all the statements. 31. Define a plane. Prove that every first degree equation ax plus by plus cz plus c equal to 0 represents a plane. Plane number defined to first degree equation in three variables. Singasi always plane number represent we have with the ulu. A plane is a surface such that for any 2 points A, B on it, the whole line segment AB lies on it. That is, every point on the line segment AB lies on the surface. Second part. Let P, whose coordinates are x1, y1, z1, and Q, whose coordinates are x2, y2, z2, be any 2 points on this. Then these points, the coordinates of these points will satisfy the equation 1. We get this equation 2 and 3 respectively. Multiplying equation 2 by n and 3 by m and adding, we get this equation. Dividing in term by m plus n, we get this equation, which is equation 4. That is, the point is lies on locus 1 for any value of m and n. But this point lies on the line segment joining the points P and Q. Thus, every point P and Q lies on the surface. Hence, this equation represents a plane. Question 31. Using matrices, solve the system of equations. Matrix system of equations is solved to the equation can be written as Ax equal to B, where A capital A equal to this and capital X the color matrix formed by unknowns, B color matrix formed by constants. Now, taking determinant of A, we get 15, which does not equal to 0. Therefore, A inverse exists, and hence X equal to A inverse B. We have A1, one cofactor of this element 2 or 1. We have to find out cofactors of in each element in each row. We have this. Therefore, A inverse is 1 by determinant A into adjoint A. We have A inverse this. Using this, putting this value in this equation, we get this, and multiplying, we get 1 minus 1, 2. Equating X is color matrix formed by non X, Y, Z. Equating X equal to 1 or Y equal to minus 1, Z equal to 2. These are the required solutions. Question number 32. Show that the height of the right circular cylinder of maximum volume that can be inscribed in a given right circular cone of height is h by 3. Right circular cone amagi manungda hapa volume khwaidagi chawba cylinder asigi awang h by 3 oigani cone adugi saruk ahum thokpagi ama wangba cylinder aduna khwaidagi maximum volume chawgani. Proof to. Let x is b be the radius of the inscribed cylinder, height of cone and volume of the cylinder. Then volume of the cylinder is pi x square into its height is h minus a where a is equal to, by applying trigonometry in the right triangle a z, we have a is equal to x cot alpha. Therefore, b equal to this, and expanding we get in terms of x. dv by dx and d square b by dx square, we get this. For maxima or minima, put dv by dx equal to 0. We have this, and solving x equal to 2 by 3 times of h tan alpha. When x is equal to this second order, whose value is always negative, Thus, the volume of the cylinder is maximum when x equal to 2 by 3 times of h tan alpha. Hence, the height of the cylinder is h minus a h minus put the value of this we get h by 3. Hence, proof. Question number 33. Prove that the value of this definite integral is pi by 2, 6 marks. We have this. And apply 0 to a property x to pi by 4 minus x loina thamani is simplified torani. We get this and sum up torabadi si phangani. Then sin 10 square x to sin square x by cos of phongdo simplified tore. CD 1 minus 2 sin square x thame. Sin square sin x to theta putting tore sin x to theta putting tore the limit to change torani asum si phangani CD 2 kamal lokhrabadi half the kanagi square no 1 by root 2 whole square ni trigonometry ki formula palani sin inverse of x by a formula palu si phange 1 by root 2 simplified value si phange 0 simplified si phange value simplified or pi by root 2 adorabadi this should be root 2 oigadaba. Question number 33. So that the value of this definite integral is this. 6 marks. Let I equal to this and we have to cos square cos power 4 na mathak makasu yele asuna thame makadu b10x asi b10x asi a10 theta da putting to b10x asi a10 theta da putting to rani this magi derivatives lere magi derivative si phange completely differential equation si change to si dx phange x equal to 0 pi by 2 oiba matam da theta gi value 0 pi by 2 respectively. Therefore, given integrand becomes this. In terms of theta, that we replace the common factors in log then sec square theta phange. Then mathang yena abadi simplify pukun sec 1 by cos of phongdo si phangani. 33 continued this. Cos square theta sin square theta is multiple even the degree singni masi multiple angle the change to Manav constant makai group law 2 kama mamang song pokrani then cos twice theta hoji integration log cell sisi di theta la rani si cos twice theta gidi cos twice theta gidi sin twice theta by 2 haigadabani sin twice theta sigi sida si sin la kadaba limit log cell ga se phangani which proves the reason. Question number 34. A model of calculators A, B, and C are manufactured at Factory 1 and Factory 2 respectively. The company has orders for at least 6,400 calculators of Model A, 4,000 calculators of Model B, and 4,800 calculators of Model C. At Factory 1, 50 calculators of Model A, 50 of Model B, and 30 of Model C are made every day. At Factory 2, 40 calculators of Model A, 20 of Model B, and 40 of Model C are made every day. It costs rupees 12,000 and rupees 15,000 each day to operate Factory 1 and 2 respectively. Find the number of days each factory should operate to minimize the operating cost and still meet the demand. Solve the LPP graphically. No graph paper will be supplied. Late. This should be consent over the one. Let X and Y be the number of days to operate the factory 1 and 2 respectively. Factory 1 amasung factory 2 adubu thabak sugudaba numising the X amasung Y days sing lokselasi. The problem is to minimize Z equal to 12,000 X plus 15,000 Y. Subject to the constants 50X plus 40Y should be greater than equal to 6,400. Simplified or receive assume makagi constants in a system. We formulate our problem. Graph masi graph yeglani sedet or any common reason. The graphs of the equation this x equal to 0 and y equal to are the lines ahanbagina AB anisubagina CD aduga x equal to 0 matangina EF x equal to 0 the y axis y equal to 0 the x axis respectively. The stated region EQPD with vertices D is the feasible region. At E Z की वैल्यू पुथोनी E की कोऑर्डिनेशन सिंजलगा असुमना Q की सु Z P की सु D की सु पुथोनी ख्वाइदगी पिकपा minimum adudi thus the minimum Z equal to this when number of days in factory 1 is IT and dead in factory 2 is 20. Question number 35. In a test, an examinee either guesses or copies or knows the answer to a multiple choice question with 4 choices. Examination amada question khudingmak multiple choice ni option mari mari lay kanagumba parikha thariba amana sinba ama khanga khumba ama guess tauba ama mawong ahum da khumi. The probability that he makes a guess is 1 by 3. Mana guess taraga khumba ki guess taraga khumba sina 1 by 3 question ahum manungda amadi guess tawi. The probability that he copies the answer is 1 by 6 question taruk ki manungda question amadi ningondagi selle or anodagi selle. The probability that the answer is correct given that he copied it is 1 by 8. Mahagna copied taraga chumbagi chance sina 1 by 8 ni. Find the probability that he knew the answer to the question. Mahagna khangaga khumbagi given that he correctly answered it. Khangaga khumbada chumme mana question ama khumbada chumme madu khangaga khumbagi ni haibagi probability puto. Let H1, H2, H3 be the events that the examinee guesses, copies, knows the answer. Let E be the event that the examinee answers correctly. Then P of H1 mahagna question ahungi manungda ama guess taraga khumi 1 by 3. P of H2 1 by 6 ni. But H1, H2, H3 are mutually exclusive and exhaustive events. Therefore, probability of this sum must be 1. Respective value pisilaga P of H3 to half hange. P of E by H1, P of E by H1. There are 4 options, out of which only one is correct. 4 options. 2 giman gama katani chumibadu. Mana guess toroga kumbada chumbagi, guess toroga kumbada chumbagi chance C 1 by 4 ni. P of E by H2. Masidi wang asida pirame mahana copy toroga chumbagi chance 1 by 8. Khangaga kumba have city always 1 orani. E by H3 is 1. The required probability is P of IC by E, whose formula by using base pairing we have this. Put their respective value and solve, we get 24 by 29. Mana kariguma answer machume madu mahana khanga kumbagini haibagi probability is 24 by 29. 35O. There are 3 candidates for the position of principal A, B, and C. The chances of their selection are in the proportion 4 is to 2 is to 3 respectively. The probabilities that A, if selected, will introduce co-education in the college is 0.3. The probabilities of B and C doing the same are respectively 0.5 and 0.8. What is the probability that there will be co-education in the college? Also find the probability that Principal B introduce co-education in the college. There are 3 candidates for the position of Principal A, B, and C. Let H1, H2, H3 be the events of selections of A, B, C as Principal respectively. Let E be the event of introduction of co-education in the college. Then P of H1 is 4 by 9, P of H2 is also 2 by 9, P of H3 is 3 by 9. Also P of E by H1 ahanbe A principal A na khalaga co-education hogokani haibagi chance asi 3 by 10. P of E by H2 principal B gidi 5 by 10. Principal ahum suba C principal gidi I by 10. P co-education is introduced in the college. Co-education haibagi probability D P of E ni, whose value is this. Put their respective values, we get 23 by 45. Required probability B introduce co-education. B na co-education haibagi probability P of H2 by any base theorem panjalaga silairane formula do respective value bisela 5 by 23 pangai. Ahan bagisina co-education nama introduce to bagini ani subagisina B khalaga ꯃꯗꯨ ꯕꯤꯅ ꯏꯟꯇ꯭ꯔꯣꯗ꯭ꯌꯨꯁ ꯇꯧꯏ ꯍꯥꯏꯕꯒꯤ ꯀꯣ-ꯑꯦꯗꯨꯀꯦꯁꯟꯗ ꯕꯤꯅ ꯏꯟꯇ꯭ꯔꯣꯗ꯭ꯌꯨꯁ ꯇꯧꯏ ꯍꯥꯏꯕꯒꯤ ꯄ꯭ꯔꯣꯕꯦꯕꯤꯂꯤꯇꯤꯅꯤ. ꯊꯦꯡꯛꯁ ꯐꯣꯔ ꯋꯥꯆꯤꯡ.